All right, new stream. Oh, I should change the title in Twitch. Can you change the title while the stream is running? Questions. Let's pop out the chat here. No. Chat. I need one of those prettier chat overlays. Other streamers have it. Yeah, that was that. Here. Does a speedrun to AI. Speedrun to AI is the new topic. We will keep programming until AI is made. And the word AI has a specific meaning, the way I use it. It's a thought engine based on language, which does not exist like this yet. So we'll make it. A quick recap. Last time we had this kind of program here. We invented this whole language. It has facts, it has logic rules, it has procedures which also contain English and a little bit of Python-esque if, else, for, and so on. Here there's a list comprehension, which can either be seen as a math construct or a Python construct or anything else. So this is as close to English as it gets, while still be executable by a machine. When we make a program for it, which we did last time, the whole thing is 300 lines, including the English program and some comments. And today, the idea is this here. We are starting to tackle hard problems. You have a chatbot, you have a chat, and people chat all the time. And how does the bot map answers to questions? The bot asks a question, and somebody answers, but they answer later, or multiple people are speaking, and we want to tackle the first simple thing here, but it's already hard. If you make a chatbot, this is the kind of stuff that you are worried about even before you start as a programmer. So the funny algorithm just takes any unmapped line and any question and says, okay, this is the answer to that question. It may be nonsense, it may not be nonsense, but that's the first algorithm. And it does this until everything is mapped to something. And the slightly better algorithm has a check here. If the answer is actually posted before the question, if it's not posted before the question, it says, okay, that can't be right. Although in rare cases it could be, if you expect a question and answer it, and then you answer before the question is posted. And there's an undefined predicate here. A not yet defined predicate. Is it a valid answer? And only if these two things hold, we can do the mapping. And another concept is backtracking. It comes from the Prolog world. And this is also what we are going to add here implicitly. Backtracking means that any statement that can be done in multiple ways will be done in some way first, then the rest executes of the script. And later, if we have time to go back or need to go back, we go back to the statement and say, are there other ways to do this? And we do that, and then we continue again. So we get a whole tree of execution instead of just one execution run. And obviously here you can choose any of the unmapped questions for X, and that gives you the backtracking. Some drugs, I need it. Backtracking could also be called something else. What you do is you take one instruction stream and you splice it. At this point, it splits up into multiple alternate realities, alternate instruction streams for every X we can choose. So, how do we implement this? Also today we have robot assistance.
Robot assistance.
His name is William.
His name is William.
He's British, as you can hear. So, oh, I think the keyboard layout was better on the lab for noise reasons. Although this is really better. Is it loud or not? I don't know. Keep it safe, I guess. Okay, so a new question arises. So it is. Now I done lost my Windows. Decision time.
Decision time.
It's decision time. We have this code from last time, and we can do one of two things. We can copy and paste, or we can make a class and then subclass it. Computing is full of these decisions. Programming is full of these decisions. When we have AI which assists us in coding, these decisions will be easier. Because if you copy and paste some code somewhere else, the AI will keep track of what you did there. And if you later change this code, it will change it in both places. We really need AI to assist with coding. Let's make a class here. Standard class philosophy bot1. I could use the term logic engine, but I think I have like 3 classes called logic engine already. So philosophy bot1. This is all generic, generic, generic. Here's some main program. I guess run is appropriate. Let's call it parse program. We need to put the program somewhere. Yeah. Program. It's just a string. Parse program. No, what was called think, I guess. Parse program. And there was a slight problem with the last program. It deduced everything fine. From I have RAM, it deduced the question, what is the size of my RAM, which was the point of the program. But up here you can see it did 100 logic rounds. And it stopped after 100 because that was a hard limit we set. It did not really have a notion of I'm done now. It did not deduce a million facts or anything. It all runs fine, it just doesn't have a good... I have a sore throat, I'm sorry. It just didn't have a good detector for the end of the operation. I have this any action here, so if it added a new rule or new fact, it says I did something, but that doesn't seem stable. Let's do something better, let's have a counter. Int size or whatever, size. We take the number of logic rules we have plus the number of facts we have, and this should give us an indicator of how much results we've produced. Because I think every action will increase one of these. I hope that is true. Indicator for end of thought process. When this stays stable. This may not really be true. Oh, let's add one more. Okay, plus procedures executed. Just a counter. but we should make it a long value, 64-bit value, because we want to do more than 2 billion calculations in big programs. So it has to be a long value, 64 bits. We can afford that. It's okay. So in run procedure, we increment the counter. So this is not needed anymore. And last size, we calculate the size. Do some logic. Don't need this here, don't need this. But in the end we check no changes exiting. In general, it's a hard question. When is your thought process done? Right? Because in real life situations, you can think further about a topic. Or maybe sometimes you actually know you exhausted a topic in your head. It's a meta function of the brain to understand its own thought processes. The brain is pretty amazing. Standard class. Defining philosophy bot 1. Okay, this is a logic engine without any actual program. And let's right away, reminder, this is a program we want to do. We need the while construct. We already have if and for and now we do while. Conditioned body. Okay, I should get out of the ugly editor and go into the prettier editor. I want pretty.
I want pretty.
Okay, this is the module that repeats what I say. Oops. I repeat everything you say.
I repeat everything you say.
Intelligence level 1 or 0 or 1, 0.5. Intelligence level 2 is saying you instead of I. Intelligence level 3 is thinking about stuff, and so on. Okay, this is the better editor. We're adding the while statement. Parsing should not be hard. It's exactly the same thing as if, actually. While, yeah, new while, done. That was easy. Now we need to execute the while here. For, is it like an if or is it like a for? It does repeat something. I think we don't have this yet, this kind of operation. Command is if. You can express a while as an if with a recursion. Yes, let's do that on paper, in the editor. While x do something is the same as if x something. Okay, yeah, that's this procedure P is the same as procedure P this. If the condition is true, do something and then you start over. It's logically equivalent. So let's do that. While this. Okay, yeah, we check the condition. Okay. We check the condition. If it's not true, we just return. And so it is true. So we run a new procedure. We kind of want to post the procedure so it's run later. Also thinking about it, this might be, no, this one, no, this is okay. If we run it right here, it's overloading this little procedure here. Also, we're getting into recursion, and then we have a stack limit if it's a long loop. And also the idea in this AI is that we don't execute the program just line by line, and that's it. But at any point we can stop, and we can say, stop, let's think first. And we can choose not to do this, but do something else instead. We can always switch between executing and thinking about the program. Another new idea that nobody has done before. Nobody does this. Java does it a little bit. Java runs your code and at the same time thinks about your code and optimizes it so it runs quicker. Java is pretty cool, actually. So we have something here, procedures to run. Yeah, we want the parse procedure in here. Not the unparsed, but the parse procedure. We have a function here. No problem. Type is object. Here, if the parsing fails, we just print it. Well, okay, because now we can just add it here and it will be run later. And we have no recursion problem. Procedures to run, add just a list of the main body as we saw here, plus the whole function. What is the whole function? It's this, I mean the whole command is this. That should be a while, actually. Three problems. Oh, wait, okay. Okay, our procedure type. You can actually declare this. Replace proc Procedures are a list of statements. So in fact, we have this type. And we have this type. And that will not solve the problem, but almost. Or does it? Let's check it out. Run parse procedure. Check it out. P-call is always good. It means run and allow exceptions. Just continue if there's an exception. Okay, where's my offending statement? Here. Cannot convert from long to int. It is true. We could use this new auto thing in Java, but they added it recently, and I'm still kind of reluctant to use the latest Java features. Java features. They sticked to Java 7 for a while because they supported Android, and Android was Java 7. Now I do Java 8. Android is updated. Okay. Just the tiniest problem arising from overuse of copy and paste. Okay, this is this. Now we duplicate the editor. Boom. New text. And we use this kind of little bot here. Use this base class. And philosophy. But random variable names. Let's make a new one right here and say who's called what run is what it's called. What program is program. I can't decide if I want to sit straight or slouch. I just don't know. Conflicting programs in the motor system. Conflicting programs. There's a slight delay after I press the button. I have to wait a second, I think. Conflicting programs.
Conflicting programs.
This is from Google Speech Recognition. Funny how it says program, MME, in British sometimes. Sometimes it uses the American version. They couldn't decide, I guess. Not sure if there's a switch for Google Speech Recognition between British and American. I don't know. Let's just do a little test program in our new great language. X like Y, I like X. Not good grammar, but who cares? Because this should execute, right? Should do something. Let's see. No changes exiting, but it didn't exit, did it? It did not exit. Where's the other error? What am I doing? Did I misname this? I did. I am clicking aimlessly here. Aimlessly. Here we have it. What's up with this exiting thing? Okay, it prints, but it doesn't do anything. That's pretty good. Fix that. That was the old program. Transpile this. Wait for the results. Okay, it has a logic rule. It did not parse this. Okay, it's just a trivial bug. If it's a single line, it doesn't notice effect. There should be parse as effect. Oh my god, I'm hungry. But the stream has priority. Where's our general parsing thing there? I'm using noise reduction in OBS. I think it's alright. I would want an actual good microphone setup. I want an investment actually, so with an investment I could get a proper microphone. Find logic rules unparsed. Assume the unparsed stuff consists of facts. Add fact. Do we trim it? Yes, we trim it. We do not want spaces in the beginning of our facts or in the end of our facts. That's just awful. Okay. I think this program should work now. It's not good English, but it works. Here's the program. I like you, X like Y, Y like X, U like I. No output. Okay. A lot of debug stuff. That's okay. Let's test the while statement maybe. How do we run a procedure right from the start? How about that? Maybe we do start. Yeah, that will work. Yes, start. Procedure while. Okay, we have two facts. The facts are start and true. And we say while true, print I am here. We have this print statement in our fancy language. Let's see what happens. I predict 100 print statements. Yes, but I think it coalesced them into one. It doesn't print multiple times, I guess. Okay, so it did a lot of rounds because while true, sure. The size is growing because number of procedures executed is growing. Okay. It's a new language, it works. It's pretty cool. So we could get back to the actual task at hand. While there are unmapped questions, how do we implement this? We have like a list of, first of all, we need some input. Oh, this is just cool. Let's save this. While true in philosophy engine, and it works. Let's keep it for posterity. It transpiles to 6,000 lines. Not that much. This is nice. This is what I've been wanting to make for years. Okay, next thing. While they are unmapped questions. Okay, let's dump the whole algorithm here. Proc. Funny algorithm. So this, we have to define this here. We want a data structure behind it. Okay, what is the data structures? Unmapped lines, unmapped questions. Some sort of list. And I mean, the idea to recapitulate.
Recapitulate.
The idea to recap is to mix Java and English. So some things are natural in Java, some things are natural in English. This here would map to a Java construct, which is a list. So we want to tell this to the bot in some way. Not up in here, I guess. We do this here while we initialize this engine. It's a predicate, native predicate. There are unmapped questions. And this is a lambda. You're returning a boolean. There are unmapped questions. The list of unmapped questions is not empty. Here. And you can also do the next thing already, I think. Here, this find statement, it would take one. Yeah, how do we do this? Now it's getting tricky. Tricky. Find negative statement. We choose a random one for now. That's the idea here, but if we random assignments, find is supposed to make a random choice. Let's be as straightforward as possible here. Just assume this function exists and implement it then. We assume x is a variable. Variables are kind of global in this thing. Bot assign variable random. There should be a way for the statement to fail though. Maybe we declare it a predicate actually. We stick with this predicate thing. If empty, this fails. If it's not empty, it succeeds. Okay. So we need this native predicate thing. Head body. Just add it somewhere, right? And then kind of, what is it? Is it a logic rule? Is it a procedure? We need it while we execute procedures. Check condition. We do need it here for sure. This is pretty tough. Because what if this takes a while to compute? What if this here is not an instant thing, but it takes a while to answer this question? Then this whole function should be in limbo, kind of. Limbo. Exactly.
Limbo.
Until this is resolved. Because we never want to get caught up in some tight loop we can't get out of. We always want to say the next thing is put into some list first and later it is run. So maybe we need to restructure the whole execution logic here. What if this doesn't return? Check condition doesn't return, but it is a continuation. Yeah. Kind of. It is a logic rule. No, it's not logic. Yeah, this is really pretty tough. You're lacking multiple things here. Also, the assign to variable thing is not possible with this architecture right now. Oh, this is turning out to be tougher than I thought. Because the variable mappings are kind of hidden. As soon as we assign a variable, we just rewrite the whole thing. Wherever there's an x, we just rewrite it to its value. Haha. We make a distinction, I guess, between things we know instantly and things we don't know instantly. There are unmapped questions. I mean, maybe let's do the simple stuff first. Yeah, let's do some simple test program first. Let's make another copy. Counter in philosophy engine. Let's just make a little counter. Transient in value. Count. Less increment. Let's just directly put this in here as the name of the predicate. And this predicate, think I. Native predicates. Nope. Native predicate. All right. Now we'll add the predicate, but not do anything with it. Zero, a function with no arguments. IF0. Okay, it did not do anything. see if it does something, which it doesn't. Okay, now we can put this in here. Check condition, first of all. Default to false. Maybe print something here. Ignoring condition. If the condition is a known fact. Yep. And then we go through the native predicates. And then we kind of do where's the gazelle zip here? Zip a condition with fact word by match word. This is a central function. If you have a pattern and an input, it matches these. Okay. Central pattern matcher. Okay. Now we can use this as a zip function. Here. Zip its head. More like the other way around, I guess. I don't know. Doesn't matter. It's not going to work. Let's do another thing. Let's put the number of rounds in here. Ah, I think some stuff happened. In fact. Max rounds. Let's go to 1,000. 1,000 is good. Oh, let's check my... Okay, enough space. Okay, so now we have a little problem. This increment is not interpreted as a statement. It's just a fact and it's there, so yeah, exactly. We have this predicate here, so we want that. Let's do that quickly. Run procedure. Okay, if it's one of the statements, we do that here. Native predicates. Run native predicate. Try object means return if not null. You run a predicate, you check a predicate, I guess. Who cares? If there's no matching predicate, we return null. And now we're almost there, I think. Run native predicate. If there's a result, if it's false, we kind of stop this, right? Exactly. And if it's null, we say it's a fact. Fair enough. Does it work now? It might. It might. Yeah, it does. See here. Incremented I to 1, incremented I to 2, incremented I to 100. And after 103 rounds, 100 action rounds and 3 preparation or post stuff. There's always a last round that does nothing. Because after this nothing round, it says, okay, now I'm done. Because in the last round, nothing changed. Then I'm done with thinking. No facts, but this counter does work. This is getting good. Can rename. Do I have rename here? I don't have rename. That's a bad. That's a bad. I should have rename. Okay. We pretty much never lose running programs, and for multiple reasons. Every snippet I added here has a history, so you can always, if you want to, restore old versions. Here are all the changes. You can look at the old text. So you can always say at some point in time, some date, how was my program? What did it look like? You can always restore the old version. We could also keep the transpolations in Java. We do not really keep them yet. It's so much data. But you can actually always restore any old program state in my language. That really eases the mind. Okay. So we have while, we have native predicates. Back to the task. Okay, this can be done now, it's not a problem. And this, yeah, this is a thing. If this is a native predicate, it needs to return an X. And it needs to tell us if it has multiple solutions. So it's an extended version of a native predicate. Okay, how about we just extend this and just forget the bool? Body can return bool. Immediate result. Okay or fail. And you can return a map. This is a map from string to string. Variable mapping. Okay, now this is a little bit more complicated. Run native predicate. Return var mapping or null. Result. If it's true, we return an empty mapping. In any other case, we return. Oh no, we need something else, which means not applicable. We don't know is an answer we need. How do we do that? We need fail and we need don't know. Ay. That's annoying. There's this optional class in Java, but it's pretty new and I don't like it. So we need something else. Let's be really ugly right here. Var mapping bool or null or no matching predicate. It also means we can just return this right away. Ret results unless okay, change of contract. False. No, actually that's okay. Not applicable. Ah, this is all bad. This is not right. Ah, no, okay. So yeah, so we never return null here. Okay, it does. It's pretty elegant. Yeah. Okay. So here we want a variable mapping. So if result is not null, then the native predicate fired. Otherwise, we add it as a fact. Exactly. If it's false, we say no, no, no. So now it must be a mapping, actually. No. Continue. And so now we assume it's a mapping. Now we apply mapping. Yeah. Let's restructure this loop real quick here. And var not null. And we make this list so we can rewrite in case of variable mapping. Map. Okay. Replace code tokens. Let's make this into a function. These are simple functions. Make a pattern matching and replace variables. Replace vars. Okay. If the map is empty, we do nothing. Yeah, this is gonna fail in some cases. Do non-string cases. First procedure here. Here. Mapping. Apply to all remaining commands. Do we have that? Do. And continue. Well, let's print this because it's so magic. Rewriting with var mapping. Applying var mapping. True. The scope of variables, I haven't really decided yet. We don't have map to linked list. Map to set maybe. Linked list in this case. Keyboards. Tiny bug, not a problem. And another standard function made. No, not made. Not made. Now. Made. No. This whole thing was nonsense. Kind of. It's the typeless version. Now we had. That's solvable. Aha. Boolean we return, otherwise it's null, we skip through. If it's a mapping to we forget the mapping. And return true. Oh, this is the old program that will still work. Will it? Yes, it will. We wanted to make a new program. To here. Match questions and answers. How many code editors do we have? Only these two. Hello. Go in here. Here. Here, not this, but we return the mapping. Here. That might actually work. How long have we been streaming? Wow. So long already. Transpile, okay. Oh, it's loaded. Okay. Turns out we didn't even start the algorithm. Here. Got procedure. Okay. Yeah, let's just debug some stuff. Add some print statements. Debug native calls. And default to true, whatever. No. Yeah. Holy moly. That. Now we should see what's happening. Yeah, it's just stupidly printed. Native prefix results. Here, there are unmapped questions false, which is true. There is no input, we have no input. Okay, let's put some questions in there. What is the time? How do you feel? Let's say the bot asks 2 questions. Okay, it returns true all the time, so we have 1000 rounds of essentially doing nothing, but it should do something. find an unmet question X. It should execute this native statement, predicate, whatever. Okay, run. Why is this not called? If debug all commands, main command, debug it. Debugging helps.
Reading helps.
Debugging helps.
Debugging helps.
Okay, the command. Yeah. It's treating these as one line. It's a parsing problem. Parse procedure. While. We do not parse the contents, which is, of course, stupid. Here, the same thing. And also here. And here, locked one. Yeah, well. If it's a list, we recurse here. What? I think we misspelled somewhere here. Yes. So, are we any closer? Aha, that looks different. Running command. This looks like an exception. Yes. Oh, it's true. Oh yeah. Uh-huh. Uh-huh. It's true. Oops. We're going a bit against Java best practices here because we allow different types to be mixed. Just return an object of this type or a fast type. We're ignoring Java type. Whatever. Can't think of a word here. We're doing untyped Java basically. It's just easier to do right now. Sometimes it's the way to go. Just return object. Okay, transport. Looky here. Unimplemented command. Nope, not a problem. We should get exceptions to print in the module, not only here. Unimplemented command again? Are you kidding me? What the heck? Why did I just fix this? I just, oh, I didn't save. Ouch. Ouchie. Okay. Yeah, find an unmapped question. X, how do you feel? X, what is the time? It is doing that. It is doing it. Let's print the result of the variable replacement to be sure that it works. Here, applying var mapping, null null. Ooh. Yep. Place vars. Okie dokie. Nope, an error. Okay. A and B and B and A and forget the type. Okay, next attempt. Make it work this time.
Make it work this time.
Okay. Okay, pretty good. How do you feel? It's, but this here needs brackets. We definitely need brackets here because this looks confusing, definitely, to a human and to a machine. Map values. Opt. Curly. Curly cursive. Opt round. We want to add round braces if there's more than one token. Round. Because now we're using round brackets. Round base opt. Round brackets. Round bracket. If not round bracketed, but we need the safe version with tokens. And we need one last function called round bracket. And close in round brackets. Round bracket. Opening and closing. Hope that's it. Oh, not round. Brackets are important. If the system forgets brackets somewhere, everything fails, I guess. Yeah, this is very good. Map, what is the time? Yes, X has been replaced by the question it found. Good. Good, 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 good. So we can do the same thing for the lines. So now the question is if the X and the Y, this is the yeah, variable handling. And almost, yeah. There's something missing, but we do that later. First, we need some actual lines to be mapped. Here, unmap lines. Let's make it hard and put them in the wrong order. Good. Early morning. So put them in the wrong order. Confuse the engine. It shouldn't matter because it just randomly chooses assignments. Find an unmapped line. It returns something. Yeah, the problem should arise with the lines thing, because the predicate expects an X, but we supply a Y. So we have to rewrite the variable mapping. In fact, yeah, it's here actually. We need to retain this. Yeah, just do it here. If it's a map, and if we rewrote any variables, Phew. X, blah, 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 da, da. Oh. Out of coffee, man. It's bad. Out of coffee. Out of coffee.
Out of coffee.
I want to apply a map to a map, basically. Map keys. Result. OS we already used. And we want to do it in the right direction, which I believe is the right direction. Look up or keep. Rewrote. Advanced AI. Advanced problems. We need a better signature here. Oh, these are going to be loads of parameters. Map A, B, C, map B, C of map A to B. No, A to C. And a function from A to B. BC, AC, AB, ABC. I think it's correct. Nope, what do we do? Okay. Look up or keep. Let's try. Applying var mapping. Haha. No, it's not what we wanted. So the predicate takes an argument x. Yeah, we do not want this x to mix with the other x, in fact. Is a new local variable or something. For now, let's just use another letter. See how that goes. Find unmapped line. Y. Running command, find unmapped line Y. And doesn't seem to do anything here, which is weird. Let's reinstate the gazelle zip print. Yeah, Z is mapped to Y. Okay. Okay. Oh, it's correct, yeah. And now it rewrote to the other variable name. Early morning. Yeah, it's done. I just didn't save before, I think. Oh man. The AI should remind me to save my texts before transpiling. Okay, map how do you feel to early morning? Yeah. It's the wrong mapping, but whatever. It's what it's supposed to do. Map what is the time to early morning? Yeah. Here we have that. Close all the helper things here. Right, it actually did it. We have it. Yeah. Map what is the time to good. Map how do you feel to early morning. And the correct mappings. My question is, why does it return all the results? Oh yeah, okay. Because it just keeps going. This never changes, because unmapped, we don't take them out. We don't execute this map thing here. And this is one way of, yeah, basically this could read while true now. So, because it's never ending anyway. And it's one way to do it. You just keep collecting. And because we did 1,000 rounds, and we only look for 4 things, we find these 4 things with near certainty. How about we save this? It's not exactly, it doesn't work because it should, but it works anyway. Let's make a copy of this. Works, but without proper backtracking. Very high chance. Yeah. So it mapped all the lines to all the questions. But the actual idea was that we implement this too. Let's do it. Map another native predicate. Map x to y. Yeah, the variable handling is not perfect. Note to self. So we have local variables and we need hygienic variable handling. But right now we get away with this. Map x to y, unmapped lines, remove y, no. Unmapped questions, remove x, mappings, put x, y. Mapped question 2, answer but we don't have x and y. We don't have them. We need this mapping here, right? We need a new type of native predicate. Oh, it's gonna fail. Which takes the variable mapping down. Takes variable mapping. And here we make a new function. So we have native predicates which take the variable mapping and some which just don't care and take nothing. Yes. Now we just supply the argument, which is this. Camera should move with my head. We have to return true. Mapped question to answer. Yes, it did this. But there should quickly not be any more mappable questions. That's what confuses me. Here's a list of unmapped questions, and we remove from those. So why does it still doing the loop? This loop here should end. Did we confuse the order here? Argument order? No. Oh boy. Where's the bug? We have these brackets here. I think we should throw them out for the native predicates. Let them not vary with brackets. Let them eat cake. Whatever. Here. Not values. D round brackets. I believe that's it. This might make it work. Okay, it exits quicker because, yeah. Yes. Exactly. Mapped question, how do you feel, to answer early morning. And after it removed 2 questions, it has 0 remaining questions. So it exits. So this is a different way to interpret this program. We execute this, and after a quick while we're done. But now we could implement the backtracking, because here there are 2 options. Also here, so we could later do some backtracking. So maybe as a last thing for now, because I think I'm not going to do the advanced version of the program. This was the advanced version. I'm getting tired, I guess. So as last thing for today, we will try to make this backtrack. That's going to be interesting. Is it hard or easy? I'm not sure. I am really not sure. Hard or easy?
Hard or easy?
Who knows?
Who knows?
So we are here, we are executing a command. So we basically just save a procedure for later with the other results. Okay, first we do backtracking. This can remain as it is, and here is the magic. This also remains almost, yeah, no. Here we need backtracking, which means we undo this thing. Basically, we do something and we return a continuation that will undo this thing. So we can explore other options, because otherwise this mapping is never reverted. So here we need to return an undo. with undo. Basically, we can do it in the same manner up here. Yeah. It's just a callback thing. Runnable. Next option. And we kind of return whatever it is with the next option. However that works. Here, maybe this. Alternative, maybe. With alternative. So the alternative will first undo anything done. And then, yeah, this is going to work. We have a, oh, I have a very cool class here. Oh, yes, yes, yes. Shuffled iterator. I posted this to Stack Overflow, but in the wrong place, so they were angry and deleted it or whatever. Stack Overflow is so stupid. Instead of honoring this, it's a great function. It iterates over a list in a shuffled way, in random order, but nothing twice, and it knows when it's done, and it only consumes the memory you need for this operation. If you take 3 elements out of 1,000,000, it just allocates a map with 3 entries. And every step is really fast too. This is just a great little function. And now we can use this one. Because we want to iterate in a randomized order. We almost don't need it anymore. We could just iterate in order. But why not, for the fun of it? Let's do that. We should clone this though. Now we have an iterator, and there's nothing. We do return something that's not runnable. It's a function. Return nothing, and if we have the next one, exactly. And in fact, I think we can now just do this. Now this is the core of our backtracking thing here in the native area. In fact, this should be false. Yeah. Same thing here, so that's a little bit annoying. We should factor out a function there. And just give this a shorter name. Okay, yeah, but it cannot refer to itself. Oh, it can. Can it? Yes, can. Okay. Do lambdas have this? Oh my god, I'm not even sure. Java lambda. This. They don't have it. Oh my holy moly. Okay, yeah, that's the thing with lambdas. They don't have it. So it's not a lambda, it's something else, doesn't matter. Now it has this reference. Okay. With alternative for backtracking in native predicates. So alternative. What? Did I delete my window? Man, that's not smart. Yeah, we're back. Stupid software. With alternative. It's just a record. It's not used yet. We can declare it. And whenever we run a native predicate, we expect these with alternative things. If result cast with alternative, have alternative. And we just use the actual result. Cast. Go. Okay. I think this might work. We are halfway there with the backtracking. No, we're not. With undo, what the heck? Okay. With alternative. So the purpose, yeah. The purpose of the alternative here is to just undo what we did and then say fail. Turn true here, and then we add it again. We will not add it in the same position. which hopefully doesn't matter. And then we return false. And did you notice? Wrong variable. Okay, let's print this. Print undoing helping of oh, we don't even load it. Didn't load this. Not loaded. Okay, have alternative. But the alternatives are not executed yet. What do we do with those? We could, I believe, simply post them as new procedure. Now we introduced order because we are changing these variables here. We have side effects. So it has to be later, actually. It needs to be not randomly, but later. So how are we going to do this? Basically, the whole procedure returns an alternative, returns a continuation that we can later invoke. It's not simple here, really. We kind of produce a trail of backtracking points, starting from the last command actually, and then incorporating previous backtraces too. So here, this produces the, when this is, after this is run here, we have a backtracking object which is carried around, and in the end, if you execute it, it will undo this first. Then this will fail, and then it will go to the previous statement. Look for more options there. Then it finds one, it goes here again, here. So maybe it's time for a new subclass here. Backtrackable. Oh. Pretty much this. It does one step of backtracking and leaves you with another object that you can call again, if you so desire, or null if there are no more options to backtrack. So, okay, it's tricky, but I think we can do it. Parse procedure. We also have the while to take care of. I mean, the while also factors in here. We should start with a simple case now. First. Yeah, it's maybe too much for the stream. What's the count? 2 hours, 12 minutes, whatever. Yeah, I think it's too much right now. I believe it's possible. We add the backtracking here. We almost have something like prologue already. We kind of built our own prologue here. Slightly different in the way it actually does things, but similar results. You need to link these backtracking objects, the one from this line to the one from this line before, and it's not completely trivial. So I have to think about that a little bit. But it's going to be done. All right, Speedrun to AI will continue.